All right, so we're gonna go and break down those problems that you just sent to me. And I'm actually gonna first start off by looking at this right here, which is just this little chart, and he gave to us in class, and it can kind of help you point out some of these things. And it's not from too long ago, but here it is right here on the screen just so you can have it. All right, so we're gonna go and move into what we were talking about here. So we're gonna start off with A, and then we'll move our way down to C. So right off the bat here, they already give you, they've done all the hard work. They tell you exactly what it's gonna be. So they basically are telling us, hey, look, it's an elimination reaction, and you can see that, right? Because there's nothing being substituted into the spot, firstly. And then on top of that, you can see that it's forming a double bond, which is what happens in elimination reactions, right? It gets rid of something, and then that double bond forms. So right off the bat here, we can go and cross out A and B. We already know it's not substitution. So furthermore, we're gonna look right here to, well, actually, before we look at that bromide, we're gonna say, what's the difference in E1 and E2? Well, this one right here is gonna form a carbocation, and this one will not. So no carbocation for this guy. And then carbocation for him. And now all this question comes down to is, can you tell if this reaction right here is likely or not likely to form a carbocation? Which is gonna make it pretty simple. So we'll go into that right now. Bromide is one of the alkyl halides. So I'm gonna write those all down right here. We've got fluorine, we've got chlorine, and these are all minuses, of course. We've got bromide, and we've got iodide, correct? Now, of these 4 alkyl halides, only 3 of which are actually good leaving groups. The fluorine actually makes a terrible leaving group, and the way to remember this is fluorine is not a strong acid, or hydrofluoric, so that's not a strong acid, right? However, HCl, HBr, and HI are all strong acids. So basically, I guess you could call them the conjugate bases, are all going to be weak. However, this one is not a weak conjugate base for fluorine. So these 3 are all weak conjugate bases. And this one is a strong, this one's actually a stronger base, which would basically mean it's not gonna be a weak conjugate base, right? This is just gonna be stronger. So that's how you can remember those. So going from there, that would kind of point you towards this bromide is gonna wanna leave. Now, something that actually will help this bromide leave, so furthermore, the fact that bromide is already going to want to go, it's one of the faster ones. It's the second fastest of the group. Iodide being the quickest, then bromide, and then chloride, and then fluorine. So we go and go quickest leaving group, Lg, and slowest, Lg. And that's kind of your spectrum there. So from there, we're going to say, well, bromide wants to leave, and it would form Br minus, right? So it would form this thing with, here, let me get my hand out of the way. It's going to have all the electron pairs around it, and it's going to have a negative charge. And then from there, you're going to say, well, it does have a negative charge, so it's not totally happy away or being away from this thing, because here it's content. It's got a neutral charge. There's no need for it really to leave. However, then you look over here, and you're going to want to look at this species first. So this right here is the species that you're reacting it with. And there's something about this species that will point you towards one thing or another here, and it's that it's going to make that bromide happy leaving, because when this disassociates in solution, you're going to be left with CH3, 3CO minus, and you're also going to be left with Na plus. Well, Na plus and that bromide with the minus sign are going to go together really well. They're opposite charges, so, and obviously, like they said, it's going to form NaBr right over here with that plus side right there and the minus sign right there on him. So that would kind of lead you towards thinking, hey, maybe this probably isn't going to form a carbocation. And that was how I figured it out. That from there was all that I needed.